So to make this work, you've got to start out by choosing a height here. What did you guys choose for a height? 10 millimeters? Okay. From that, then, we're going to calculate the distance from here to here. What do we get for that distance? $11.50. Okay. So this is our 41 degrees. And then this distance from here to here, which will be 19.626 millimeters. Of course, this is the 27 degrees. So what that means is that we have a triangle on the top here. This one up here, it looks like this, where this is 11.504, and this is 19.626. What do we want to find out of that triangle? That angle, what is it? Does that look right? I would have probably rounded to 382. We'll go 30.38. What do we need to find next? If we draw that in, yes, this angle here is 59.62. And then what else do we need to know? That is, by the way, R. We need to get this distance across here, which is 9.926. This angle here and this side, that's going to be a cosine opposite over hypotenuse. Because now if we're looking at this triangle, the 19.626 is now the hypotenuse of that one. Sine, yeah. Did I say cosine? Yeah. Because the sine of 30.38 is opposite over hypotenuse. So that 9.926, that's this length right here. So what we're going to look at then is this triangle here. This is the 9.926, and this is the 10 that we just chose to begin with. This here is our angle of tilt, which is going to be how much? 218, we'll go 22 degrees. So that's our tilt. This is the inverse tangent of the 10 over the 9.926. We're going to try something a little different today. Well, I want to see how much of this you guys can come up with on your own. We know the thought process. So we're starting with our block. And as we mentioned yesterday, what we're going to do is we're going to cut it here at a bevel. So we're going to cut that bevel off like that. But then we're going to cut it here. Oops, I'm going to do this. Sorry. We're going to cut it here at a bevel as well. That sounded a little painful. So what we're going to do is if we look at this from this side, I'll give you that this angle here is, oh, let's go with 50 degrees. And if we look at it from this side, I'll give you that this angle here is 40 degrees. So what I'm really creating here, if I cut this and this, what I'm really creating here is a box again. If you guys can see it, we're running from that back corner up to the front corner. Here, I'll draw in this back little. That makes it look more obvious. So we need to find once more this angle of rotation, and we'll call this our angle of tilt. So I'm going to give you guys a few minutes to see what you can come up with. I'll even give you this. Take this out all the way like that. This height and this height will be the same. This distance and this distance will be different, but those will be those dimensions on your back. Okay, so the hint I gave you is to pick a height here. We're gonna make that 10 millimeters. Of course, this is 10 millimeters. We can now use those angles to find these dimensions here, which I'm going to call A and B. And that would just be dimension A and dimension B here. So A here, this is going to be a tangent of 40 degrees, will be 10 over A. Is that what it comes out to be? 11.918 millimeters. Cross multiply and divide 10 divided by tangent of 40. Same thing up here. 1 times 10 divided by tangent of 40. Yep, 11.918. So up here is tangent of 50 degrees equals 10 over B. So yeah, put that over 1, we cross multiply and divide 8.391 millimeters. So what we have, this goes back to that problem we did on the very first day of doing this lovely stuff. Where we had 10 millimeters here. This was at 11.918, and this was 8.391. Okay. I don't know why I said 9. 8.391. So what we're looking for here, our angle of rotation is just this angle R right here. How do we find R? Okay, we could do that, or we could just do this here is going to be a right triangle. Here's R. I think you got something backwards, by the way. This is 8.391, 11.918. Inverse tangent of 8.391 over 11.918. I think your first number was the right one. $35.15, yep. So you didn't need to do the complement. Next, the angle of tilt we used before was up here. We're using this one now, angle of tilt. To do that, we have a triangle here. Here's T. We know this is 10, that distance we chose. We don't know any of the other dimensions of that triangle. Let's say I want to know the length of that compound angular surface. That length would be found using our three-dimensional Pythagorean theorem. Square root of 10. There you go. All that lovely good stuff, right? Giving us 17.676. So how do we find t from that? Opposite over hypotenuse. There we go. Inverse sine of 10 over 17.676. 3445. So that is our tilt. What do you guys think? It is done in two separate operations. We're just defining that surface, that corner is all. We're not defining an operation. Let's mix things up a little bit. Why not? Right? Right here. Come on. Time to replace my batteries again, apparently. Yeah, 2.1 inches. I want you to do the same thing here. Define that surface for me with that rotation and tilt. I want to see what you can figure out there. Okay, so if we're thinking about this box again, this one actually is easier than the last one. It's just maybe a little more difficult to visualize. The height of the box here is the difference between these two dimensions. 1.2 inches, very good. This dimension here is the difference between those two. 0.7, right? This one is the difference between these two, which is 1.25. So then, this is my rotation. R is going to equal the inverse tangent of perfect. 29.25 degrees is my rotation. Now then, to find my tilt, I'm going to find the length of that first. That length will be the square root of 1.25 squared plus 0.7 squared plus 1.2 squared. .869 inches. So that T, which is this angle here, we have 1.2 here and 1.869 here. That'll be the inverse perfect. .95 degrees. What do you think? Better than a sharp stick? Yeah. Once you get it into that regular box that we started out with. So, in our lovely packet, page 416 through 1 through 14, again, I'm not expecting to do them all. Pick out 3 or 4, that look like they're different types and give them a shot. That does wrap up what we're doing here. Tomorrow we'll review. Thursday we'll have our test. Maybe what I'll do is when you leave here tomorrow, I'll send you with the test. You can ask questions on Thursday. Speaking of tests, does anybody have that angular drilling quiz? I've got from 2 of you so far. Yep. It says 62 and 63 on the top. Yours was yesterday, yep.